Welcome to another episode of Learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems from the question paper IIT JAM 2025. Today we will be discussing the solutions of three problems from group theory. It is the final part 2 of the two parts. And these questions are suitable for all these examinations. Right. This is the question number 39. It is a multiple MSQ, multiple select question. There can be more than one answer and it carries 2 marks. For n belongs to n, consider the set U of n is equal to the set of all x bar belongs to Zn such that the GCD of x comma n is equal to 1 as a group under multiplication modulo n. We know this is a group under multiplication modulo n. We are very familiar with it. Then which of the following are true? It's a multiple select question. There can be more than one answer. We are given 4 options. Option A, U8, U of 8 is a cyclic group. Option B, U of 5 is a cyclic group. Option C, U of 12 is a cyclic group. Option D, U of 9 is a cyclic group. Right. Now first we go to the option A. U of 8 is a cyclic group. What is U of 8? Write down all those integers which are relatively prime to 8. 1, yes. 2 is not relatively prime to 8. 3, yes. 4 is not. 5, yes. 7, yes. So it is 1, 3, 5, 7. U8 and all operations, that means the operation is under multiplication modulo 8. Right. Now a clear observation will tell you 1 square is 1 modulo 8. 3 square 9 is congruent to 1 mod 8. 5 square 25 is congruent to 1 mod 8. 7 square 49, 8 6 are 48, it's congruent to 1 mod 8. Note that x square is congruent to 1 mod 8 for all x belongs to U of 8. Further, what you see is 3 into 5 is 15 modulo 8, 3 into 5. Now what you see is 3 into 5 is 15 modulo 8 is 7. Right? 3 into 7, 21 modulo 8 is 5. 5 into 7 is 5 7 are 35 modulo 8, 8 4s are 32 is congruent to 3 mod 8. Right. So that means every element other than the identity, its a square is congruent to 1 mod 8, and multiply any 2 of 3, 5, 7, you will get the third element. 3 into 7, 5, 5 into 7, 3. So these are some of the properties what I am saying. This is a Klein's 4 group. So U8 is isomorphic to K4, that is the Klein's 4 group. Is Klein's 4 group cyclic? No, it's an abelian group but not cyclic. Right. U of 8 is not cyclic since K4 is not cyclic. Thus, U of 8 is not a cyclic group. The option A is not true. Right. We go to the option B, option C. U of 12 is a cyclic group. Write down the elements of U of 12, all those elements which are congruent to which are x comma GCD of x and n is 1. So write down all those elements which are relatively prime to 12. 1 yes, 2 is not, 3 is not, 4 is not, 5 yes, 6 is not, 7 yes, 8 is not because the GCD is 4. 9 is not, 10 is not, 11 yes. So again you got 4 elements and note down 1 square is 1, 5 square is 25, multiplication modulo 12 is 1, 7 square 49, 12 fours are 48, congruent to 1 mod 12, 11 square 121, 12 tens are 120, it's congruent to 1 mod 12. So note that x square is congruent to 1 mod 12 for all x belongs to U of 12. Further, 5 into 7 is 11, 5 into 11 is 7, congruent modulo 11. 7 into 11 is 5, congruent modulo 11. So this is, again, it is isomorphic to K4, the Klein's 4 group. You have to remember what are the defining relations for the Klein's 4 group. U12 is isomorphic to K4. So U12 is not cyclic since K4 is not cyclic. Therefore, the option C is not true. We move to the next slide. Right, we take option B. U5 is a cyclic group. What are all those elements? What are all those elements which are relatively prime to 5? 1, 2, 3, 4, 5. Because 5 is a prime. 5 is a prime number. Now, notice that here, take this element 2, 2 square is 4, 2 cube is 3, 2 power 4 is 1. That means 2 generates all the elements. Congruence modulo 5. So that means 2 is a generator for this U of 5. Thus, U of 5 is a cyclic group generated by 2. Right. So, option B is true. Move to option D. U9 is a cyclic group. Write down all those elements which are relatively prime to 9. U9 is 1, 2, 4, 5, 7, 8. Agreed. Again, you take an element, this element 2, and 2 square 4, 2 cube is 8, 2 power 4 is 7, congruent modulo 9, 2 power 5 is 5, 2 power 6 is 1, modulo 9. That means 2 generates every element of it. Therefore, U of 9 is a cyclic group generated by 2. Yes, it is a cyclic group. Option D is true. We have already seen options A and C are not true. Now options B and D are true. Therefore, the answer to this question is options B and D. That is the detailed discussion of the solution of this problem from group theory. And it is a very simple and straightforward question. Right. This is a numerical answer type question. numerical answer type NAT for 2 marks, and it is a question number 52. Let sigma belongs to S4. It's a permutation, be a permutation defined by sigma of 1 is 2, sigma of 2 is 3, sigma of 3 is 1, and sigma of 4 is 4. So it's a permutation, fixes 4. Right. The number of elements in the set consisting of all those permutations from S4, tau belongs to S4, such that tau sigma tau inverse is equal to sigma. Is equal to tau sigma tau inverse is equal to sigma means it is a conjugation. Say all those taus under conjugation it fixes sigma. Well, how many elements are there in this set? We are given sigma belongs to S4 defined by sigma of 1 is 2, sigma of 2 is 3, sigma of 3 is 1. That means 1 is mapped to 2, 2 is mapped to 3, 3 is mapped back to 1, and 4 is fixed. So it is, sigma is a cycle, 1, 2, 3, fixing 4. So what is this? Sigma is a 3 cycle. Let capital X be the set of all tau belongs to S4 such that tau sigma tau inverse is equal to sigma. This can be seen as X can be seen as the set of all tau belongs to S4 such that tau sigma is equal to sigma tau. That means all those permutations which will commute with the sigma are in X. Right. That means it is the normalizer of sigma. It is the normalizer of sigma, and we want to find order of X, that is the order of n sigma. So the order of X is equal to order of normalizer of sigma, and you recall a formula for that, that is order of n of sigma is equal to order of G by order of CL of sigma. What is CL of sigma? It is the conjugate class of sigma. It is the conjugate class of sigma. Right. And remember, how many R cycles are there in Sn? Is a general result. The number of distinct R cycles in Sn are NCR, the symbol for NCR, multiplied by R minus 1 factorial. Why do we require this? Because we are talking about 3 cycles. So how many 3 cycles are there in S4? That's what we want. The number of 3 cycles in S4 is, so S4 means N is 4, 3 cycles means R is 3. So here NCR 4C3 multiplied by 3 minus 1 factorial, and 4C3 multiplied by 3 minus 1 factorial is 4C3 is 4C1 4 into 3 minus 1 factorial is 2 factorial, that is 2. Multiplication is 8. Now we are ready. It is known, right? It is known that any two 3 cycles are conjugate. In Sn, any 2 R cycles of length R are conjugate. So all 3 cycles are conjugate. And sigma is a 3 cycle. What will be the order of the conjugate class of sigma? All of them is in the class because they are all conjugate. How many permutations are there which are conjugate to sigma? And there are 3 cycles, and they are all conjugate. Therefore, the order of the conjugate class of sigma is 8. Now we are ready. Order of X is equal to order of normalizer of sigma is equal to order of G by order of the conjugate class of sigma. That is equal to 4 factorial by 8. 4 factorial is 24 by 8, that is 3. So order of x is 3. Therefore, the answer to this question is 3. That is the detailed discussion of the solution of this problem, and it is an interesting problem. Right. We move to the next question. Yeah, this is the last question. Question number 60. And for 2 marks, this is a numerical answer type question. Now, the number of surjective, that is onto homomorphisms from S4 to Z6 is equal to the number of surjective, that is onto homomorphisms from S4 to Z6 is equal to dash. Let phi be a homomorphism from S4 to Z6. Assume that phi is a surjective homomorphism. And what is Z6? Z6 is always cyclic. Zn is cyclic. So when it is cyclic, let X be its generator. So let Z6 be a cyclic group generated by X. And what will be the order of X? It generates Z6, therefore order of X is 6. Right. What is phi? Phi is a surjective homomorphism. Where is X? X is in Z6. So what is phi? Phi is a onto homomorphism. Therefore, X is in Z6. Because it is an onto homomorphism, it has a pre-image, call it A in S4. Since phi is a surjective, X is in Z6, X has a pre-image, let's call it as A in S4, such that phi of A is equal to X. Right. Now, we have phi of A, phi is a homomorphism, right? Order of phi of A divides order of A whenever phi is a onto homomorphism. So, order of phi of A means phi of A is 6x, order of x divides order of A, order of x is 6, 6 divides order of A. What is A? A belongs to S4. So, order of A will be a multiple of 6, that is 6, 12, 24, stop there, because S4 order is 24. Now, look at S4. What are the orders of elements of S4? If you are familiar with S4, every element is of order either 1, R2, R3, R4, that's all, because it has only 4 elements. So, notice that every element of S4 is of order 1, R2, R3, R4, right? That's all, nothing else. Right. Somebody is thinking that why not 6? Suppose if there is an order 6, then it should be written as the product of disjoint cycles of a cycle of order 2 multiplied by a cycle of order 3. When they are disjoint, 2 and 3, 2 plus 3, 5 elements should be there. But in S4, we have only 4 elements. Therefore, these are the only type of elements. So, there is no element A in S4 of order 6, 12, 24. Thus, order of A is not equal to 6, 12, 24. Right. So, no homomorphism from S4 to Z6 is surjective, because your assumption is wrong. Therefore, no homomorphism from S4 to Z6 is surjective. Therefore, the number of surjective homomorphisms, that is onto homomorphism, from S4 to Z6 is equal to 0. There are no surjective, that is onto homomorphisms from S4 to Z6. Therefore, the answer to this question is 0, and that is the detailed discussion of the solution of this problem. And in this video, I have discussed the solutions of 3 questions from group theory. They are all simple and straightforward questions. Right. I am sure that you have understood the solutions of these problems. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I am sure we are going to meet you again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.